Okay, this evening I'm going to give you a short summation of significant figures, significant digits, how to round your answers when recording values from simple addition, subtraction, multiplication, division calculations. Okay, let's start with multiplication and division. They share the same rules when rounding answers. The rule is your answer has the same number of significant figures as your least significant figure quantity. So, for example, right here 3.241 has 4 significant figures. 1.8 has 2 significant figures. So, when we calculate these values, 3.241 times 1.8, we get 5.8338 square centimeters. So what the calculator says. But we have to round this answer based on the limitations of these two values. 1.8 is 2 significant figures. 3.241 is 4 significant figures. So our answer can only have 2 significant figures. So we take the first 2 significant figures, 5.8, we'll record those, look behind them to see if we need to round our answer up to 5.9 or keep it at 5.8. 338 rounds down, so we record our answer as 5.8 squared centimeters with 2 significant figures. Now we move to a division problem. 28.501 is 5 significant figures. The 0 is squeezed between 2 non-zero digits, therefore it's significant. 3.76 is 3 significant figures. All non-zero digits are significant. So when we put this into the calculator, we get 7.580053191 grams per milliliter. But we have to record our answer to only 3 significant figures because we're limited by 3.76. 3 sig figs versus 5 sig figs. So we take the first 3 significant figures, 7, 5, and 8, look behind it to see if we need to round up to 0.59 or keep it at 0.58, and 0.0539191 rounds down. So we're going to keep it at 7.58 grams per milliliter, 3 significant figures. Okay? Now, when we do addition and subtraction, we change the way we look at values. We don't look necessarily at the total number of significant figures, 4, 2, and 2. We focus in on digits of precision, decimal placement. So when we go to add these 3 quantities together, we share the tenths decimal. All 3 quantities share the tenths. So when we put this into the calculator, 2.109 plus 3.2 plus 0.81, and the calculator says 6.119 grams, we can't record that as our answer. We have to record the answer with the decimal placement, the precision that is shared between all 3 quantities. So we'll record 6.1, the tenths position is shared. We look behind it to see if we need to round up or round down, keep it the same. 1.9 behind it will keep us at 6.1 grams. So we're focusing in on the decimal, the digits of precision. Here we have 2.51 kilograms minus 1.8 kilograms minus 0.002 kilograms. This is 1 significant figure, 2 significant figures, and 3 significant figures in the values. But when we're subtracting or adding, we look at the digits of precision, the decimal placement. What are we sharing? All three of these quantities share the tenths position. So when we solve this, 2.51 minus 1.8 minus 0.002, and the calculator says 0.708 kilograms, we have to round our answer to the common decimal, the common digit of precision, that tenths position. So we'll have 0.7, look behind it, 0.8 would round it down, would keep it at 0.7 rather than 0.8. So we round our answer to 0.7 kilograms. Okay. Addition and subtraction, we focus on the decimal, the digit of precision that is common and shared between each of the quantities involved. Multiplication and division, we focus in on the number of significant figures that each quantity is bringing into the calculation. Okay? I hope this helps with rounding and recording your data and values from calculations and from lab experiments.